Hello, I'm Mike from Grove Streams. In this video, I discuss stream derivation from expressions. I will briefly give a high-level description of stream derivation from an expression, model some examples, and go over when stream derivation takes place. I will not go over stream derivation troubleshooting. This is done in a separate video. Grove Streams manages time series data as streams. Streams can be populated manually via file imports or externally from one of our APIs or connectors. Or they can be populated using one or more other streams. We call these streams derived streams. Derived streams are streams just like all of the others. They can be used wherever streams are used, such as in dashboards, events, and queries. They have roll-up statistics available, and they can be used by other derived streams. Streams can be derived several ways. This video is going to cover derivation from formula expressions. What is meant by formula expressions? Here's one example. We can have stream D just be a copy of stream A. The formula expression would be stream D equals stream A. All stream data, historical and future, will be copied into stream D from stream A. Here's another example. We could also have a stream C be the sum of stream A and stream B. The formula expression would be stream C equals stream A plus stream B. All stream data, historical and future, will be derived as the sum of stream A and stream B. You get the concept. Now let's model those two expressions so that we know how to implement them in Grove Streams. I'm in a Grove Streams organization that is utilizing branding. The Grove Streams logo has been rebranded to a GS Flux logo. We're going to model these two from scratch. First, I'll create a component. I'll give it a name, derivation examples. Next, I'm creating three 1-minute interval streams. Stream A, I'll make the data type a long, which is a non-decimal number, set its base cycle to 1 minute, and I'll set its roll-up calendar. Then I'll just copy it and rename the other three. Let's model the first example, which is stream D equals stream A. Select stream D, select the derivation tab. Change derived from to expression. Set the effective date to the start of today. The derived stream will only derive from the effective date to later dates. Add stream A as the expression variable. We can click the Add button and select a stream from anywhere in the organization. If the stream belongs to the same component, it's easier just to click the Pin for Drag and Drop button and drag the stream. We want our expression to be everything on the right side of the equal sign. So for this example, it will just be stream A, which has a variable name of var1. We could rename var1 to stream A, but I'm going to leave it as var1 so it's understood that the variable name is used in the expression. There are use cases where the same stream is used multiple times in one expression. That's when having different variable names makes sense. Let's save the component and test it. Stream D now has an icon that signifies it is a derived stream from an expression. Double-click stream A to open it. Let's enter a couple of values. Double-click stream D to open it. Stream A's data has been copied to stream D. Notice the copy data aligns exactly with the date times. Let's add another value to stream A as if more data is flowing into it. Stream D is now copying all new data that flows into stream A. Let's do the second example. I'm deleting all of stream A's data from the previous example so that the next derivation will recalculate the entire stream. Let's add some data to stream A and stream B. I'm going to make sure there's a gap in one of the dependent streams. Gaps happen. It's good to know how derivation responds to them. A good way to validate and diagnose derivation is to use the time series dashboard widget so that we can see all of the streams together with their values grouped by interval end dates. This is important, so I'm demonstrating that now so that you'll know how to do it. The derivation engine will execute the formula expression on each set of intervals for each end date, which is A plus B for each row. So 10 plus 1 equals stream C's value 11, and so on. It's important to understand that the stream value date times must align for them to be used in the same expression. This goes for regular streams too. I can't stress that enough. Derivation by default only occurs for values that have matching date times. There's ways to work around that by using rollups with the last statistics or by using the last value system variable, but I will not be demonstrating those in this video. Point streams used in expressions are treated as constants and used for every date time or for every row in this example. If the derivation engine encounters a gap, the result will be a gap. This is the default behavior, but know there are options to handle gaps in expressions. Let's edit a historical value and see what happens. I'm going to fill the gap too. The derivation engine detected the historical changes and recalculated all of stream C's values from the earliest historical change. With the gap filled, that row has now calculated. If you ever want to rederive a stream, just right-click on the stream and delete all of its values. Then wait a couple of minutes for the derivation to run on the job servers. A good derivation design should produce the same results when the derived stream's data is deleted and a recalculation occurs. Results should be repeatable. Next, I'll demonstrate deriving from smaller intervals into larger intervals. Let's derive a day stream from a 1-minute stream. I'll create stream E, but with a base cycle of days. I'm making the date type a string so that we're also demonstrating deriving into a different data type. Let's sum A and B's daily sum. We choose the day cycle and the sum statistic for each. Let's do a derivation that says display A greater than B and report the difference. We can leverage the if statement and string operators to pull this off. Okay, what happened here? Why is there only one value for stream E? The derivation engine ran one time to process only 1 day's worth of data since stream A and stream B only had data occurring in 1 day. It grabbed that day's day sum from both stream A and stream B and then used those values in the formula expression. Notice that the day cycle being calculated is today. Today is still ongoing. Let's see what happens when more data arrives for stream A and stream B during the ongoing day. Stream E's value has been updated. That interval will keep being updated until the end of the day, and then the next day's interval will start being calculated as dependent data arrives. This example demonstrated using rollups, deriving into a larger interval, and converting the result to a string. Let's view a few real-world derivations. This component is from the smart plug sensor used by GrowStream sandbox organizations. It has several derived streams that have already been modeled. I'll quickly go over them. This sensor is uploading temperature as Celsius. Here's a derived stream that converts the 5-minute Celsius average to Fahrenheit. Remember the conversion formula from high school? 9/5 times temperature Celsius plus 32. This stream is calculating cost per second. It is using the ampere stream and the energy cost per kilowatt hour stream. This stream is calculating a rolling 3-point average. It's leveraging the interval offset feature and checking for gaps using the isNull function. This stream is calculating the monthly cost to run a refrigerator. It's using monthly rollups from the current stream. It's also using the base interval count for the month to obtain the number of seconds in the current month. Notice the different types of comments allowed in an expression. One more. This derived stream is using another derived stream as a dependent, which is the cost per second stream. For the energy folks watching this, time filters can be applied to streams, so we could be calculating on and off peak energy and costs. Time filters and holidays will be covered in another video. What else can be done in an expression? Click the Derived Functions and Details button to see a list of everything that is supported. All derivation errors are reported with job notifications. Click the Notifications button to bring up notifications. Double-click the notification to see the actual error. When does derivation run? Every minute or two, all derived expression streams that need deriving will be processed by the derivation engine across all of our job servers. Not in real time, but it's highly scalable. Derivation will run in real time if any dependent stream has data modified from the admin UI, if the dir_max_s parameter is included in HTTP feed put API calls, and for all MQTT feed publish calls. See the real-time derivation video to learn more. Utilizing both of these techniques allows derivations to be scalable and real-time. I know you're thinking, wow, modeling derivation is easy. And yes, it is easy when you're using streams that are the same type, have all the stream interval sizes, have the same data types, and data is arriving at the same time. Yes, easy, but that's not always the case. There will be times when you'll be asking yourself, why isn't my stream deriving? That's why the next video is going to be troubleshooting expression-derived streams. You should now have a general understanding of expression-derived streams and how to model them. Combining real-time rollups, real-time derivation without any programming makes GrowStreams one of the most powerful and versatile streaming platforms in the cloud. Thanks for watching.